Okay, so now we're going to venture away from frequency and go towards our measures of central tendency and measures of spread. And we're going to do this only for continuous data because a lot of these you can't do for categorical data. For discrete data you can do it, but it's a little bit boring, I suppose. Okay, but I'm going to do it only for height. Okay, and you can go ahead and try it for discrete if you want as well. But we're going to do it for height. Okay, so doing most of these things for raw data is so ridiculously easy that you're going to say, wow, I'm surprised I didn't just figure that out myself. Okay, so first things first, I've got here in red raw stats. Okay, so I'm going to do a raw mean. Okay, now if you don't know what to do, well, sometimes the best thing to do is to go to the function, press fx, and see what you can do. And you can even put in here mean if you want to, and go ahead and search. But there's nothing really that kind of relates to mean, because the words that they use for mean, even though we use them often as well, is they use average. Okay, so you use average. Now what you'll find for most of these is there are a lot of different averages. Okay, there are a lot of averages for populations, for samples, with all kinds of different arguments and all kinds of crazy stuff. We're going to keep it relatively simple, and usually if you go for the most basic for a population or the most basic for a sample, then you're going to be in good shape. Okay, so in this case I'm going to pick average. Okay, there's usually a little descriptor. Let me make it a little bit smaller here. Oops, I'll have to get out of that. Make this a little smaller, and then we'll go fx again. And in some of these cases, when you choose something like average, it actually will give you more help on the function, or will give you a description of the scenario. In this case, when I go to insert the function, and it's inserting here by raw stats over at average, okay, it does sometimes give a little bit of a description as to what it's all about. Okay, it depends on the version of Microsoft Excel that you have, but it's still a good thing to read that description to make sure you have the right one. Okay, so in this case, what you have to do is you have to put in your data set. It wants to know what you want to do your average for. So in this case, I want to do it for this, and of course I'm going to, once I have F2 to F21, I'm going to be using that a lot. So make sure again you copy that, and then you can paste it in whenever you want. Okay, and it even gives you a result down here already, but you press done. Okay, and then you've got your particular mean. There it is right there. Now there's other ways that you could do it if you wanted to do it. You could add them all up. Okay, like just to prove that this mean is correct, if you don't believe it. You could add it all up, so you could do a sum here. Excuse me. You could do a sum here, insert the function, and then it's going to do F2 to F21 already. Go ahead and go done, and you get 3,460. And then here you could write below it, just go ahead and say, make your own formula, equals this divided by 20, press enter, and you get 173.025, but that's exactly the same as the mean here. So we don't need to do it as a raw calculation, but you can do it from a raw calculation if you want. It's again, it's most simply done just by looking at the fx. Really, and then for all these, it's pretty easy for your raw stats. I probably made that a bit too big, but anyway, this should take us almost all the way there. Now for variance and for standard deviation, there are different formulas for populations as well as for samples. So this is where you're going to have to make sure you pick one for a population or pick one for a sample. Okay, same thing for variance. Okay, that was what we did for mean. You go up, you look up fx. Now in this case, you can actually search up variance if you want to. Okay, and go ahead and search for variance. What happened there? Okay, so they want you to put in var in this version. This is the version that my daughter has, so it's a little bit different. Now they've got var, they've got var p, var s. If you have a population, you use var p. If you have a sample, you use var s. And the difference is, of course, for a population, it's going to divide by n. And for a sample, it's going to divide by n minus 1. So you have to know what you're dealing with. This is a sample of my classroom. If I'm talking about all students in the school, or even all grade 12s or grade 12 math students. It's not all the grade 12 math students, so it would be var S. But if it was all of the students in my class and I was only concerned about my class as a sampling frame and as a population, then var P is what I would use. In this case, I'm just going to pick var S, okay, because it's always better to be more conservative if you're not sure, okay, because that's going to give you a bit larger of a deviation anyway. So insert the function, okay, and then what do? Again, you have to go ahead and you have to put in the particular values, okay, so we're going to paste in F2 to F21, that's our data set, okay, and then press enter, and then done. It even tells us the result right there. Okay, and the variance is 153.775. Now remember, of course, that the standard deviation is square rooted for that, and we did have a fairly variable set of data. The lowest value, I think, was 146 or something, and the highest value was 200. So that's quite variable when you think about it for all those particular values, but we'll go a little bit more to that when we go to max and min. For standard deviation, same idea. Now, it may be an abbreviated version, STDEV, and there it is, STDEV rather than standard deviation. And again, you got standard deviation for P for population and standard deviation for S for sample. You definitely have to keep it consistent with what you did for the variance, and we did a sample version of that. So we select that function, we insert that function, and then again we put our data set in there. Fairly simple, fairly straightforward. No big deal. And so our standard deviation is 12. So we've got a mean of 173.025 and a standard deviation of plus or minus 12.4. Okay. When you get to confidence intervals and all kinds of other features that go along with that, and we look at probability distributions, and we look at the normal distribution curve and z-scores and all sorts of things, then we also are going to want to use all of those values, and they mean different things to us. Basically, if we have a normally distributed data, which is sort of a normal thing that we would see, or a common thing that we would see for continuous data, then to have a population, 12 standard deviation, or one standard deviation of 12 values above the height of 173 and 12 values below the height of 173 gives you about a 68 to 70% probability based on the shape of that function. Okay, but there are variations on the theme. So we're going to get more into that if we get to that by the end of the year. We'll see. Okay, for the rest of them, max and min, you can do these a bunch of different ways. I've never searched this up for max, actually. This is again my daughter's. So there is a max actual function. Okay, so you pick the max function, you insert it. Okay, and you use your data set. Okay, again, and then you paste it in there. And then you go done, and it gives me my highest value. You can go ahead and look that up because you only have 20 values. For a min, same idea. Okay, and you go to the function. Okay, and you have a minimum value. Insert, and then don't forget again your data series, your data set, F2 to F21. Go ahead and be done. And 146.5 is the lowest value. Now we also had something for a measure of spread that related to highest to lowest. You can actually get things to be ranked highest to lowest, but I won't do that because you usually have to modify your data sets, and I don't want to do this in this case. But for Q1, Q3, Q2, Q3, so the Q2, which is the median, you can search up as a median or you can search up as a quartile. And you can do quartile 1, quartile 2, quartile 3. In fact, the max you can do is quartile 4, and then the min you can do is quartile 0 as well. So they're kind of useful. And then the interquartile range, we should just do a simple calculation for that. Okay, but for Q1, what we do is we look at the fx, the function again, go up. And then for Q1, we want to look up quartile. Okay, so you look up quartile and you press quartile and you go insert. Okay, and then the array, that's actually the data. Okay, it's a fancier word for it, but it's the data array. It's like the range, it's like the values that you put in. And then for the quartile, you have to put the number for the quartile. If you want the min, you put 0. If you want Q1, you put 1. If you want the median, you put 2. If you want Q3, then you put 3. And then if you want the max, you put Q4. So in this case, I'm going to put Q1 because I want Q1. I press enter. And then it's a bit convenient because then you don't have to modify your data set, and it'll tell you exactly what that median value is. Now we don't have a 166.5, which means that must be an arithmetic average between two values. Remember, we had 20 values, so that would be probably between the 5th and the 6th data value there. Okay, the median would be between the 10th and 11th data value when ranked from lowest to highest. Okay, you can go ahead and look up median. I think this probably has a median function. It does. Okay, but if you want to use the quartile, you're using it for Q1 and Q2. You can, and it's just convenient because you can use the same function over and over and over again. Same array. Okay, you paste that in there, and then for the quartile you put 2. Done. And then for Q3 you just do the same thing over and over and over again. Insert, and then paste in your data array, your data values, and then you put in 3 for Q3, and then you're done. Now for your interquartile range, you can just do a simple calculation. Remember, it's Q3 minus Q1, so I go Q3, boom, minus Q1, boom, okay, and then you go ahead and just press enter, and there's your 12.75, okay, for your interquartile range, or from 179.25 to 166.5. And you can, of course, tell that that's 12.75. Okay? So that's how we do all of our single variable stats for raw data. Very, very, very easy. Okay? For measures of central tendency, mean, and median. Oh, I didn't do mode, did I? I actually didn't try out mode for this one. Probably should put that in mode. Okay. Let's try out mode. I'm sure there's going to be a mode function in there. Forgot our 3 M's. So there's a mode, insert. Okay, remember, don't forget your data array is your data. Okay, and then you go ahead, done, 165. Okay, that's the most commonly occurring value in there. I don't know how often it occurs. There's no score for it, but you could probably go ahead and look it up, or do a frequency for 165, and you can find out how often it occurs, and from that you can get, how large that bump may be. Okay. Now for grouped data, it's a little bit different. So it's going to be a much more long and involved process because we have to do a grouped mean and a grouped standard deviation, and it doesn't do it as an f at x function. So we got to do it from scratch. So we're going to do that as a whole other video, and that's going to be the last of all of our videos, I think. Okay, and then we'll have this data set. You'll have all these videos, and you'll be able to try this challenge yourself, and then of course be able to try to answer some of your questions the same way. So I'll talk to you later.